Okay, yeah, a little bit about myself. I've been at Verkada for a little under 2 years, and I lead up all CV and analytics on our product team. So all of the AI features that you see with Verkada, I work very closely with our engineering team and help bring those into the market. I've been working on CV and AI across my tenured career, both in small tech companies and now at scale with Verkada. So very exciting. And today I kind of want to take you through a little journey of what we're building and just how Verkada is continuing to push the envelope on AI innovation and bringing technologies to the forefront to video security. So, we recently announced a whole new way to search through AI-powered search. So you might be wondering, what is AI-powered search? So I guess maybe a show of hands here. How many of you have used the Verkada system and are familiar with AI-powered search? Okay, a handful, but that's exciting because I saw fewer hands than I was expecting. So we're here to learn a little bit more. It's really a whole new way to search, and to really the end goal of this is to help protect people in places and in a privacy-sensitive way. It's really still core to our mission, and it's a way of bringing in new technology to help you to search quicker and faster. So maybe worth setting a little bit of context. Here at Verkada, bringing in new technologies is not new to us. We've been using AI features really since day one. We were founded in 2016. Our first set of cameras was put out in 2018. And what you can see is we've really incorporated that type of technology from the very start. And so here's a little timeline. When we first started, we had concepts of motion search, right? Being able to set a specific plane in a point in time and kind of show you where different motion was triggered. Now, that was really a great start, but what we found was you're constantly having to kind of sift through a lot of footage to find the relevant piece of information. And so from there, we really introduced, in 2018, 2019, new CV and analytics into our platform. So being able to search for people and search for vehicles, and specifically looking at types of attributes, person wearing a blue shirt. And that's, nowadays is, I think, pretty standard. Back then, it was, pretty new. But I'd say, since then, what we've started to do is bring our models in-house, and I'll touch a little bit on the importance of that and kind of our architecture and why that allows us to innovate. But we were able to bring our models in-house, which then allowed us to have more sophisticated and advanced analytics. We rolled out things like LPR, being able to read license plate recognition based off of OCR. And I'd say in the last year and a half, we've really taken off, specifically with bringing AI, because we've been able to kind of roll out things like MotionX and being able to do high resolution vector matching on our images. And our big launch in Q2 was on AI-powered search, and I recently worked with the team to announce our AI alerting. And so I think what I really want to emphasize here is this isn't just like one feature that we've launched. It's really a journey that we've been on incorporating new technologies throughout our journey of being a company. So what I want to spend today on is diving a little bit into some of these new and innovative features. So you might be wondering, how does this all work? Well, one thing I will say is Verkada is a hybrid cloud solution, and because of that, that gives us a lot more flexibility on how we're able to actually leverage these new technologies. And so there's a key thing here that our device comes with kind of the latest CV chip, which allows us to do a lot of compute on the edge, and it really is an efficient and performant model. And this works very closely with our cloud architecture because it allows us to take in filtered data and really incorporate large and powerful models that you see out in the market today. Now, why does this matter? I think of this as like the pensieve from Harry Potter. You're able to kind of dive in to our analytics on the edge and take out only the relevant pieces of information to compute on our back end. So let's dive a little bit into the architecture on the device. So on the device, what we see is the device itself is taking in different snapshots. And on the device, we're able to kind of trigger whenever motion's detected, and we're able to do things like object detection. And so what you're seeing is that the chips on the edge are basically processing and helping us filter through relevant pieces of information. As it's sifting through that relevant piece of information, it's storing and being able to sort out kind of a high quality image that we can then send to our backend. And so what's happening here is, rather than sending every piece of information that that camera is seeing, we're picking and choosing the relevant pieces, and we're being able to send it in an efficient way to our backend. So by the time our backend or our cloud receives this information, it has its relevant metadata associated with it and is able to make sense of what happens. And so you go from a core set of what we like to call hyperzooms, being able to zoom into a specific and relevant piece of information, and you're able to kind of infer from it. And so this is an example of our MotionX search, where these images give you a sense of path and purpose, and our backend is able to kind of compute this on a model and kind of draw that trajectory to say, where did this person go? Versus just, hey, I spotted a person. So that's a little bit about our on-device architecture. Now, for our cloud architecture, how does this manifest itself? So now that our cloud has kind of stored that metadata and said, okay, I've been able to plot out the direction and where individuals went, and have that stored metadata on, tracking that specific person, our cloud architecture takes those hyperzooms and then, based off of the different attributes that you as a user are using in our system, is able to extrapolate and serve you that relevant information. And so part of that metadata might be, I'm looking for someone in an upper body wearing a blue shirt. Well, we've stored that in the cloud. It's a lot of metadata to store, but we can serve that for you. Or face search. Find me a face that matches with the faces that you've stored in your cloud system. Or even AI-powered search. Hey, I'm looking for two individuals walking down the street. Very broad, very general, right? And so our hybrid cloud architecture really allows us, one, to find the relevant information on the edge, which can be tough, especially in like low latency environments, but then puts it into our cloud environment and we're able to scale that. So let me dive into a little bit of an example here of how that actually works. So for our AI search, you might be wondering, here are two images, right? How do I make sense of this? Well, with our AI search, part of what we're able to send to our backend is we have a visual language model that is able to vectorize all of these images. And for simplicity, we're going to vectorize to an X and Y axis. But you can imagine that all these images that are stored on our backend, it's a pretty wide set of matrices that we store to make sense of the data. But in this case, we have two separate images. So one here looks like, if anyone, probably 7 of you drove with this into the lot today. I see plenty of these on the highway. It's a white Tesla. And then we have a person walking through our office, actually. And so through our visual language model, we're able to vectorize and say, let's store and categorize these into pieces of information. And so our open source language model that we use, Clip, stores this, and says, hey, this image is 1-1, versus, hey, this is a car, it doesn't really look like this other thing. Why don't we vectorize it and say -4, -3? And so you can imagine we're storing this vast set of information in our system. We host it locally, so it's an open source, but it's hosted on our own GPUs in case, there's a lot of questions around like, are you sending my data to third parties? The answer is no. And so based off the model that we're hosting in our infrastructure, in our stack, we're able to actually plot them out, right? And we say, okay, person over here and the car. So that's the relative distances. Now, when you go into Verkada and you search for a query, we take that language learning model and we check our vector database and we map it out and we say, hey, I'm searching for person holding coffee. Where does that land in the vector sets that you have? Well, it says based off of the model we have an approximation that this is the vector of what a person holding coffee typically looks like. And so we map it, and then we draw an area of, I guess, relative closeness to that match. And so in this case, hey, this clip, this original hyperzoom that you have stored, that matches with what you're looking for. Now, this car is a little further away. Let's not match with that. And so in that case, we're able to serve you that match here. Obviously, depending on the search and how we store those vectors, there can be very broad or very precise. But by and large, we're only surfacing you relevant information from the system on the edge, but we're able to compute it in our backend. So I think this is just like a very high level example of what some of our engineers spend a lot of time building to make it seem pretty seamless. So I want to dive a little deeper into this flow. I don't want to bore you. I want to get to the magic and actually show you. But just from a technical standpoint, I chatted a little bit of how this works. And this up here on the top, what you're seeing is what I described in our hybrid cloud model, where our cameras on the edge have that image input. We're running this into our large language model, and then we're vectorizing it, and we're hosting that in-house on our GPUs. And so then when you go in, we match against that large language learning model, and we say, where's that match score? And then we have some thresholds, right? We say, only match with these thresholds that meet within that circle that's being described. So just a little bit more in the weeds and into how this actually works, how we actually set it up, a little bit of how the sausage is made. Now, you might be wondering, well, that's a whole lot of data. Like, what's going on here? Well, since we've launched AI Search just a quarter ago, we've already processed 70 terabytes of images, and at peak times, we're processing 25,000 images per second. And so that's not an easy thing to store on our edge. And so I keep emphasizing the importance of this hybrid cloud model and how those technologies allow us to move really quickly. It really does, because there isn't a computer chip out there that could do that kind of processing on the edge for us. Now, you might have a question. Well, like, how do you moderate this, right? It's pretty broad. What can happen? So one thing that we take very seriously is privacy. And so we have large language learning models on the queries that are set, but we also incorporate a lot of safety nets. So we actually have a moderation policy where your broad searches are actually run against a separate moderation model that we ensure is being used in the right and the safe and correct way. And so this is something that, we, as we adopt new technologies, want to be really mindful of how we put privacy first for our users. And so what we're able to do is we actually don't return results that might offend that moderation model that we have. So just wanted to touch on that because the technology can seem really broad and there's a ton of uses, but we want to continue to ensure that the system that we built in Verkada Command is still being used for privacy and sensitive, with privacy in mind. But I do have an example here. We work with a police department in North Carolina, and because of our AI search, rather than having to go in and type in, hey, I'm looking for a car that is red, that can return really broad models, they were able to use our AI search. And they said, hey, I got a call from the field with a description. And that description was, there was a red Kia van that we just saw. Can you help me find it? And so from the time that they ran that query, they were able to see we had a match. There's a red Kia van. We were able to run that query, and the police department of North Carolina was able to actually make an arrest based off of that information. And so this is just a real example of, this is cool technology, but how time and seconds matter and how we're leveraging technology to make that really easy. Rather than saying, hey, this car was spotted on this camera at some point in the last 3 hours, and you're sifting through that motion search and be like, hey, am I going to wait and see where it came? I can just go directly to that point in time. And so I think for us, we want to hold ourselves to a high standard and continuously improve. And this is just seeing those out in the real world really, I guess, motivates our team to continue building and adopting new technologies. So I'll breeze through this because it's very similar. We recently launched AI-powered alerts. I'd rather show you what that looks like. So why don't we jump into the demo? Does anybody, any objections? We'll have some Q&A after, but I just want to show you this live in action really quick. So I'm going to swap out this computer really quick with mine, and I'll show you what this looks like in our environment. If you didn't know, we have our own demo environment in our HQ. This is in San Mateo. You're looking at a live view today. What's nice is our AI-powered search is just native to our search bar here. And you can see that we have some recent searches, but in this case, something that I love searching for, I love sending my packages to the office. I like putting in FedEx driver. And so you can see here what I just described is happening IRL, and we're taking a look at all of the cameras in our system, and we're processing and saying, hey, where did you find what looks like a FedEx driver? And you can see here, it returns all appearances that we're seeing there. And some are relevant and some might not be, right? Some might be like, hey, this is a close approximation. So in this case, you're looking at a UPS driver. So let's say I'm like, okay, you know what? This was a little broad for me. So actually, in fact, I want to search for something that's a little bit more precise. So in fact, I'm going to search for more like this. And so this is kind of taking that next step of just describing something in natural language, but actually taking an image from a relevant result and serving you additional results that are close to that. And so, for us, you're starting to see very similar. In this case, you see, a couple different matches, but kind of our intention here is to go really broad with the AI search. And so this is one example. Now, I do want to jump really quick into our alerts feature that we recently launched. And so a big thing that we heard from customers once we introduced AI search was, well, this is great, but I actually want to be alerted when this happens. You do a really good job of giving me a wide net of searches, and so I can go find when something happened after the fact. But I want to be alerted when something's happening in that moment. And so we took that feedback and we said, what's the way that we can set up AI alerts? And so we recently launched this actually two weeks ago. And you can go in, just like any alert in our system, you can set what cameras you're looking for. And so in this case, let's do all cameras. And then you can set up that detection. So just like that AI search query we did on the home page, we can set on the cameras we define. In this case, I'm a parent and I want to see, hey, when is the school bus coming by? Or I'm a principal and I want, hey, is the school bus coming by on time? So let's do school bus, right? Now, we are in downtown San Mateo, so I hope there are school buses, but let's see. So it's doing the same thing that I showed you on our back end. Obviously processing based off of those searches, and you see here, okay, there are the school buses that we're seeing in the system. Now, one thing that we heard was we purposely kept AI search really broad. For alerting, there's different needs and use cases, right? Some alerts may be really important. And so we give you the ability here to filter based off of precision or broadness. And so in that example I gave you of FedEx and UPS guy, you may not really care, right? Okay, that's fine if I get a UPS guy once in a while. But you can imagine for like use cases of security and keeping bad folks out, or schools, or if there's different urgent situations you can take care of, you can be a little bit more precise. And one thing that's important is we give you an estimated range based off of the data that we see from your own system of how many alerts you'll see. So in this case, all right, this looks good to me. I'm going to set it as done. You can set a schedule and say, I really only want to see if there's school buses during the day. I don't really care for nighttime. But in this case, I'm just going to leave for all 24 hours. And then I'll call this school bus. And so just like any system that we have, any alert that we set up in command, you're able to now leverage the power of our AI and have that alert set up. And so you can see here, I've set up a couple. I set up school bus, that example of white Teslas. You can see here that I set this up maybe 20 minutes ago, and in those, we've already gotten 2 alerts on white Teslas. And I think one of my favorites is dog walkers. And so we can see, I don't know about this one. I don't see a dog. But when I set up the alert, maybe we can tweak the alert. If you edit, it had pretty relevant results. So needless to say, we're always incorporating new technology, and part of this is being able to map those visual language learning models into our system. You can see here, a little more relevant. But yeah, we're always looking to improve, and a big question that comes up is, how are you going to continue to push the envelope on embracing technology? Right now, we like keeping our system pretty adaptable. And I think the hybrid cloud model helps us do that. And right now, we integrate with an open source model that's kind of the best in class. And so as new technologies come out, we're not going to be afraid to roll them in, but we're always going to keep safety and privacy in mind when we do so. So I know that's pretty breezy at 30 minutes. I hope that was a good deep dive, but I'm happy to do some Q&A.
Mostly security-based question. Who has access to this information at your company? Because I know, like, my company doesn't want just anybody able to see video feeds, for example, and so cybersecurity is like super important. So, like, who at your company, for example, would be able to access this?
It's a great question. So I think there's two answers to that. The first is we only are able to access footage if you grant us access to it. And so within our system, I'm not even an admin in this organization, but if you are an admin, there's a privacy and security tab that you can go to. So let me switch maybe to a different org. But the gist of it is you have to grant us access in order to be able to see that footage, and it can be time-based. And so oftentimes, the only reason this ever comes up is, hey, I'm having tech issues with this one camera. Can you take a look? Or, hey, I was expecting that this alert would have been triggered and it didn't trigger. Do you mind taking a look? But by and large, no one at our company is able to access your feeds in your system unless you give direct access to. And when that access is given, we also audit log any movement that was made. And so if you're like, hey, I'm going to give you access for the next hour, in your system, you'll be able to see how it was used. Did they actually go to that camera? Did they look at what they were looking to fix? So that's my first answer. We take that very seriously. We've put in a lot of controls in place to really give you that power over security. Now, the second one is even on these search queries, we don't have access to what search queries you're making because we take that very seriously. And so the language models that we've incorporated, even our AI engineers aren't able to go into your organization and be like, well, what queries did you make? We anonymize all of our data, and we don't even allow our engineers to go into that level of detail. So the only real way that someone could say, hey, I was searching for dog walking and it really didn't work, is if you give us that feedback, we'll jump on the phone call with you and we're going to have to ask you, hey, do you mind sending me a support token so I can jump in here and see what's going on? Now, let me see if I can log in just to show you real quick. I guess who has used our support token feature? Show of hands. Okay, so if I can log into a place where I am an org admin, I can show you what that looks like. I'll take the next question while we're doing that.
Yeah, my question is, I work at a school. I'm curious if on the AI alert software you just showcased, which looks really interesting, if you could do a search that was like person with a gun that's not a police officer, for example.
Yeah. So
like what level of positivity can we give with that? And
that's a great question. So gun is a moderated search. So that is something that, again, unless we're able to do that very safely, and we don't want to roll it out, right? We don't want the false positive of where you're depending on an alert, we're not able to send that to you, and the downside is much higher on your end, right, in terms of the actual outcome. So person holding gun is a moderated search. Now, we do integrate our feeds into third-party system and softwares for individuals who do have a very high use case for that, but that's not something we currently take on ourselves. But you can search for things like, police car outside. And so your question was more around, like, how accurate is it, or in terms of?
No, I'm just thinking of the hypothetical scenario, like if we had, someone was bringing a gun to campus that wasn't a police officer, we could get notified.
Yeah.
I find that would be a huge value.
Yeah. So maybe the gun itself is not something we allow because it's moderated, but we do allow for not in our searches. And so something that we hear a lot is a little bit more in like show me person not wearing a hard hat. And so in school cases, you could be like adult not wearing a backpack, or I'm trying to think of like other use cases that we've seen. Typically we see like send me an alert if a police car is sighted, if a police car with sirens on, because that usually means it's not just a police car driving by. It's like there's a big, there's a problem that came up. So I'd say we do allow for the not case. We don't allow for weapons because it's a moderated search as it exists today. The other thing that we're looking into, which I think would be really relevant for school systems, is we have persons of interest today. So show me the bad guys. But a lot of what we continue to hear is, hey, I want to see when a stranger shows up to campus. When there's a face in the system that you haven't seen. So I'm not going to go and make all of my students POIs because that could be, really, really tough. But I want to know when a new face shows up that isn't, say staff or students. And so that's something that we're exploring. That's something that our language learning models allow us to play around with. It's not something that we've announced publicly yet, but we're exploring what that looks like as we hear feedback from school systems. Like, I just want to know when an adult shows up on campus that shouldn't be there.
Sorry, my other question is related to what protocol are these images or videos sent over to your guys' system?
It's TLS, so it's a secure protocol. There's the entire documentation on the calls, but it's a secure protocol. That's what we use.
Because I know, like recently, for example, certain bad actors have been able to hijack things like cache credentials, and I know there are ways of tapping into over-the-air feeds.
Yeah.
And so that's something that is a concern.
Yeah, so it's over secure connection, TLS5, and then the other thing is all of the video that's sent is encrypted in transit and at rest. And so even if a bad actor is able to intercept, which because of our secure connections, we feel very confident they can't. Even if they were, they need a specific set of keys to unencrypt that data. And so we feel pretty confident that that's not the case. And then a new feature that we just announced is actually enterprise-grade encryption, where today we manage a lot of that encryption in our backend. But if you have a system that says, hey, I want to manage those keys, we actually give you the ability to manage those keys with your IDP or provider.
And then one kind of follow-up question.
Mm-hmm.
How do you guys ensure that the images that are coming to wherever they're stored are not somehow altered?
So tell me more in terms of like altered in which way?
So usually, like when you send an email to somebody, there's ways that you can backtrack, or that could be backtracked so that it was sent from that person's computer.
Mm-hmm.
That it wasn't altered in transmission. It can be a concern, especially if you're using something that's like an AI-based search.
Mm-hmm.
Because if it somehow had been altered in transmission, say somebody grabbed this video and they added something to it, or they removed something from it.
So in that case, I think the thing that comes to mind is our devices, when they communicate to our backend, is always through a secure handshake. And so we ensure that whatever data and image we're processing, the source and origin of truth of that data comes from a device, a Verkada device. And our backend just doesn't allow you to take in information that's been altered in any way. If that were the case, then that handshake between the device and our backend wouldn't be successful based off of the different protocols that we have. And I think, let me see if I can go to the, forget where it is. It might be in support. If you go to org settings, support. Yeah, so this is what I was saying. Like, we can't access your footage unless you specifically here and say, I want to enable access. In this case, you can toggle it on, and then you can actually specify, I only want you to have access for a set period of time. Here's the token. So if you call our support team, this is what they'll ask for. Hey, can you generate a support token? And then you can even choose and say, I only want to limit you to this site because this is where I'm having the issue. Or I only want you to look at the infrastructure, right? I don't want you to see images because I'm having more of like a network connectivity issue. So you don't really need to see. So really, we take that pretty seriously, and we want to ensure that only you are able to kind of give those permissions and controls. And then I do want to kind of go to, let me see here, in our privacy and security, to your point, this is also an API. This is an audit log of anyone and everyone. So you can see internally in your organization who's accessing. That's something that we care about too, is who has access to the system, even internal employees, and how are they using it. And you can kind of see an audit log here. Where did they go in and what did they change? So just a good example of, we always want to leave kind of a digital trail of that to ensure that people are using the system safely and securely. I'll go back to our demo org, since that one's a little nicer than, if you can tell, the engineering org is a little bunch of cameras everywhere in our office. Awesome. Any other questions? Well, I'll be around here for a little later for if you have any ones that come up. But I really appreciate you all, stomaching a big barbecue lunch and listening to a little bit of the AI tech that we incorporate here. So I really appreciate it.
Yeah.
Thanks, everyone.